Bonjour classe. Voilà, le faisais maintenant. Just kidding. So it's French Fry Day or French Friday, and as we get the fun joke of doing our do now in French. Just kidding. Everything is translated into English. We got the Le Petit Prince standing on his little planet right there at a position of pi over 2. Your job is to find the sine of pi over 2, cosine of pi over 2, and tangent of pi over 2. No need to do anything in French. Go ahead and hit pause so you got those evaluated. Hey, nice work. Let's take a look at what our answers will be. So sine is the y-coordinate, which is going to give us a value of 1 right here. Cosine is the x-coordinate, which is going to be a value of 0. Tangent is the y divided by the x as a ratio or a fraction, and 1 divided by 0 is undefined. So we'd say does not exist or undefined. Hey, there's more do now. Um, Same thing here. We did A, B, C, and here 1, 2, 3. Nice work finishing up the rest of the Jackson 5 song on your own. Also, a nice job finishing the rest of the do now. So, hopefully, you came up with these same values. Sine of 5 pi over 4 is negative radical 2 over 2. Cosine of 5 pi over 3 is 1/2. And for tangent of 5 pi over 6, we started with 1/2 over negative radical 3 over 2, which gives us a triple stack fraction action. And we're, of course, going to want to simplify that. I changed it to a division of fractions, rewrote that as multiplication, multiplied, reduced, and came up with negative 1 over the square root of 3, which is bad syntax. That's not good math grammar. So I rationalized the denominator and ended at negative radical 3 over 3. All right, well, today we're going to continue looking at using the unit circle, using the unit circle coordinates to evaluate trig ratios. Two things in particular we're going to focus on: reciprocal trig functions and evaluating trig ratios at quadrantal angles. Here's a nice Foxtrot cartoon. I'll let you read that for a minute here, and then we'll move on. Okay, so we got our unit circle that we established previously. We remember the definitions of the 6 trig ratios using coordinates. In the previous assignment, we only used sine, cosine, and tangent, starting off a little bit slowly. And so today we're going to look at cosecant, secant, and cotangent, the reciprocal trig functions. And the other term we need to look at here is the definition of what a quadrantal angle is. Quadrantal angle is an angle whose terminal point is on either the x-axis or the y-axis. Of course, the axes form the boundaries between the 4 quadrants. So what we're looking at is 0, pi over 2, pi, and 3 pi over 2. Right, and the reason why we want to pay special attention to these is because they have kind of unique values of 1 and 0. And when we combine those in different ways, sometimes we're going to come up with some funny answers. So we want to make sure just that we're paying attention to which one is which, like we saw in the do now already. So these are some examples of quadrantal angles. You saw this in the first part of the do now. Pi over 2 is a quadrantal angle. It lies on the y-axis. So we've already seen the possible answers here. We got 1, 0, and does not exist. So we got to pay attention to which one is which. When we do the reciprocal trig functions at this quadrantal angle, we're going to get those same answers, but in a different arrangement. So cosecant is the reciprocal of the y-coordinate. We already had the y-coordinate over here from sine, which was 1. If we do the reciprocal of that, it would be 1 divided by 1, which gives us a final answer of 1. So there's no change there. Secant is the reciprocal of the x-coordinate. We already had the x-coordinate from cosine previously. When I do the reciprocal, 1 divided by 0, that does not exist. And lastly, when I do the cotangent, this is going to be the x divided by the y. Now you could just go back to the unit circle, grab those coordinates, and create your fraction afresh. Or since we already have the y coordinate divided by the x coordinate over here from our previous answer of tangent, we can just do the reciprocal. Instead of 1 over 0, it's going to be 0 over 1. And that is possible. 0 divided by 1 gives us a final answer of 0. Okay, so these are the answers that are possible when we evaluate trig functions at quadrantal angles, whether it be 0 radians, pi over 2, pi, or 3 pi over 2. Those are the only possible answers, and they're not always going to be in the same arrangement, but the only answers you will ever get are 1, 0, or does not exist at a quadrantal angle. Okay, so the other part of the do now was numbers 1, 2, and 3. So let's take a look at the reciprocal functions with questions 4, 5, and 6 here. So we're starting at number 4, cosecant of 5 pi over 4. Of course, this is the same angle that we'd evaluated previously, the sine of 5 pi over 4 at question number 1. So cosecant is the reciprocal of sine. We already had the y coordinate over here, so we could just do the reciprocal. So we ended negative radical 2 over 2. That was our answer for sine. The reciprocal of that is going to give us negative 2 over the square root of 2, which we would need to rationalize the denominator to get a final answer of. We can do that, that's fine. Or if we go a step backwards in time, when we were creating the coordinates on the unit circle in the first place, using special triangles, the side length we originally had was negative 1 divided by the square root of 2. And we didn't leave it that way because that's improper math grammar. But if we remember that's the step we had before rationalizing, we can save ourselves having to rationalize twice. We can just do the reciprocal of this, negative 1 over the square root of 2. And so the reciprocal of that is going to be negative radical 2 over 1, or just negative radical 2. Okay, that's a lot of explanation for a short answer. This is an answer that will show up 8 times for various answers around the unit circle. And so it's not something that just is like a one and done. It's something to show up a lot. Okay, number 5, secant. Secant is the reciprocal of the x coordinate. So secant of 5 pi over 3 is going to be the reciprocal of the answer we got previously for question number 2, cosine of 5 pi over 3. And the reciprocal of 1/2 is going to give us 2. Lastly, cotangent of 5 pi over 6. Okay, cotangent is the reciprocal of tangent. You could also remember it as x divided by y. We already had y divided by x when we evaluated tangent of 5 pi over 6 earlier. Okay, our final answer for tangent of 5 pi over 6 was negative radical 3 over 3 because we had rationalized. But if we take a step backwards to know where we came from before rationalizing that answer, at negative 1 over the square root of 3, if we take that unrationalized denominator and do the reciprocal, it'll save us some work right now. So the reciprocal of negative 1 over the square root of 3 is going to be negative square root of 3 divided by 1. I could just write negative the square root of 3. You'd get the same answer by taking negative square root of 3 divided by 3. That was our final answer for question 3, and rationalizing the denominator again. But that's more work. You can do it, it's fine. But if we can do a shortcut, let's do a shortcut.